Manufacturing Matters is an MFG Radio Network production brought to you by GIE Media's Manufacturing Group as industry experts take deep dives into the latest manufacturing matters, whether it's new innovations, products, technologies, and emerging markets that help you understand better why manufacturing matters to you and also to the top companies in the medical, aerospace, defense, and electric vehicle manufacturing industries. Welcome to the latest discussion from GIE Media's Manufacturing Group. I'm Jay Kaufman, the managing editor for the group of magazines, and I want to thank you for joining us for our Workholding Roundtable today. We are happy to be joined by experts from SMW Autoblock, Imugi Franken USA, and Shunk, and we'd like to thank them for sponsoring today's discussion. Now, Imugi Franken USA is a wholly owned subsidiary of German parent company Imugi Work Richard Glimpel KG, a leading manufacturer of precision clamping devices, tool holdings, taps, thread mills, drills, end mills, and other rotary tools for more than 100 years. Imugi designs, engineers, and builds work holding solutions specific to the customer's machine, workpiece, operation, and environment. And soon this year, Imugi is introducing a centric vise offering that provides tremendous clamping forces combined with exceptionally high accuracy. The new product is called the Evo Grip, and it will further broaden Imugi's high-performance solutions from table to spindle tooling solutions, and that will all be on 3 and 5 axes. SMW Autoblock, meantime, is a work-holding company focused on achieving customer goals and expectations with the highest quality products and services. SMW Autoblock combines stock standard product with a highly trained sales, service, and a sales, service, and engineering team to consistently provide the ideal work-holding solutions to customers across a wide variety of industries. The organization strives to achieve a deeper understanding of customer needs to provide products and services geared towards specific customer applications while maintaining long-term mutually beneficial partnerships to enhance machine tools and drive modern manufacturing. And Shunk is an international technology leader in tool holding and work holding and gripping technologies, along with automation technologies. Approximately 3,700 employees in 8 plants and 34 directly owned subsidiaries and distribution partners in more than 50 countries throughout the world. That ensures an intensive market presence. We're happy to be joined today by Michael Gauntz, the VP of Sales for the Tool Holding and Work Holding section at Shunk. We also have David Jones, the Precision Work Holding Product Manager at Imugi Franken USA. And we also have Larry Robbins, the President and CEO of SMW Autoblock USA. Without any further ado, I say we start the work holding discussion. Gentlemen, thank you so much for joining me today.
Thanks for having us. Appreciate it.
So, Michael, we will start with you over at Shunk. The first question I have is, what are some of the new innovations in work holding that are really driving the improvements right now for your customers?
Let's see. So I think I'd probably classify that into a few different things. So number one being, and I almost hesitate to say new these days because 5-axis technologies are actually almost the norm in the industry. And we continue to develop a lot of different technologies around 5-axis work holding. And one of which, for example, is our 2+2 Rota ML Flex chuck. And what that is, it's basically if you have a large trunnion table style 5-axis machine, this chuck is the ultimate flexible 5-axis milling, turning, work holding device for whatever work piece is presented to that machine. And I think that kind of technology is important because it offers flexibility on 5-axis machines. It used to be that, you'd buy a machine with a very specific intent in mind. You know exactly what that project is going to be or the work that you're going to be putting across it. But now more than ever, people are having these machines without knowing what kind of work they're going to put on it. And what that means is you need to make sure you have something that's universal and very flexible for all kinds of different work holding. Couple of the other trends that we're seeing is, of course, the push towards automation. So we're continuously developing our products to be more and more tailored towards automation. I think that's one of the The huge benefits that's coming out of the shunt facilities is the fact that we're going to have that complete line all the way from the work holding to the gripping device. So automation tends to be another really big one. And then we're always trying to stay at the forefront of technology by incorporating more and more devices with that are driven electronically, that are able to give more data feedback to the machines, that have more and more control. We go back to that flexibility point by having a vise or a gripper that is controlled with a servo motor. It means you actually get even more and more flexibility out of that, which brings, once again, opens up automation to lower lot sizes and to the masses, not just for high production. So I kind of leave it at that, where, you know, a focus on that 5-axis work holding, more and more automation, and then devices becoming continuously more electrified, so to speak.
Awesome. Well, thank you very much, Michael, for your expertise on that. We will now head over to David at Imugi. Now, I think I might have touched on something in the intro, but what are some of the innovations in work holding that you're really seeing that'll help the customers drive improvements in the future?
Well, a lot of innovations, like Michael touched on, is the able to adapt, right, to continue to move forward with a customer. And we are coming out with a new centric vise line, the Evo Grip line for FIC 3 and FIC 5-axis work holding. And for our company, we supply a lot of tool holders, so and tools, so the round tools, the milling tools, the drills, the taps, all that, thread mills. So we can truly go from table to spindle with that. And that's going to launch this spring, so we're real excited about that. Some of the clamping forces that we're going to provide, we have 3 different main sizes of that device. It goes from 25 kilonewtons, which 25 and 35 is kind of the industry standard. And our bigger guys get up to 35 kilonewtons, and then 25 kilonewtons. And the result is 75 Newton meters clamping pressure, the maximum on our big one, right? 100 Newton meters down the line. And it's you know, if you put that in English terms, the big one is a lot of clamping pressure, you know, something like 16,800 pounds force on the big one, right? 11,200 on the medium one. But away from that, 3D printing has been something talked about a lot, right? Whether they print it in the machine now and machine it in that machine. For us, we may give an example of like a diaphragm chuck. We have maybe interchangeable jaws or an interchangeable diaphragm. Well, with 3D printing, you can print right on top of the diaphragm itself. And then if you need to move to a next size, you can cut that off and print right on that same diaphragm all over again. So there's a lot going on, right? But flexibility, modularity, compatibility, right? And talking with the customers, where do they want to be? And we want to be with them.
Awesome. Thank you, David. So then we will go to Larry. Now, I heard Michael and David both mention flexibility. I'm going to guess that Larry will not use that in his response, but we'll ask once again.
I trademarked or copyrighted that stuff, Jake.
Yeah.
It's something I say in every presentation. If you're not buying flexibility in your product, don't buy it. You know, how many times do you get a customer that comes to you with a solution, and then at the 11th hour, they go, oh, we want to hold this part too. Well, okay, we'll try, but we can't guarantee you can hold a part from 40 inches to 8 inches in the same work holding component. But for us, the newest developments are the ability to transmit power and data simultaneously over an air gap to power vices, chucks, grippers. One of the newest products we have is automation. We're getting more and more into the automation arena. Our core product is still work holding. We sell all different kinds of work holding, but now with the electrification of work holding, we can now give predictable grip forces, predictable setups. The customer can store the information that they've built in their database and go back to their perfect setup every single time without having to guess or reset the part. Also, the ability to service a customer for their needs now and in the future. Giving customers, and I'll say it, Jake, the flexibility of having a base product that you can build off of to hold different parts. You know, it used to be people would come in and buy a special for specific parts. You're seeing less and less of that, and now they're trying to go more and more to standard components with special touching features. So with that being said, there's constant innovation in work holding, in automation, in electronics, in gripper technology. We're all kind of getting into the same arenas now. And I think I said this before, the pie is this big. And we happen to all be very friendly competitors. So, it's if people are looking for price, they're coming to the wrong company with us. If they're looking for solutions and future solutions, that's what we do for a living.
Thank you, Larry. So we'll hit the next round of questions first with David Jones over there at Emugi. So how does a company decide the right work holding technology for a project?
For us, it's always based on a few factors, but a good thing to have is a great conversation with the end user, right? What do they want? What do they need? What are their problems? Maybe they have some a current offering they don't like very much. Maybe they have a specific problem they need to challenge they need to get over. So I think it's good to have those direct conversations about their whole program. If it's a part family, right, the adaptability to that part family, fewer changeovers to the next part, right, in that family, that type of thing. But it all comes down to exactly what they need, their environment, their machine, their connection, what operation they're having. And we like to be problem solvers, right? And we like to stay with them until the problem is solved. And I think Michael and Larry can say, hey, sometimes you deliver some goods and maybe it's not perfect out of the box, but you have some adjustability and you change it and you make it perfect, right? So it's not only the sale, but it's the support after the sale as well, right? But I like to get personal with customers, right down to the nitty gritty, all the little ins and outs, right? So we cover all the bases. So when we quote something, we know we're going to be right in the ballpark of what they're looking for. And like Larry touched on, if you want to make a bad machine tool good, well, you can do that with work holding, I suppose. But you want to make a good machine tool better, good work holding will get you there.
Awesome. Thank you, David. So we'll go back to Larry with the same question. What does a company, or how does a company decide what is the correct work holding technology for a project?
The easy answer would say what David said.
Yeah.
And with that being said, David hit on a bunch of very pertinent things when it comes to work holding. I was taught growing up in this industry, if you listen long enough, they'll tell you what they want, how they want to use it, what they plan on doing in the future, and how much they're willing to pay for it. We have a large engineering group internally that does a lot of applications. Our kind of bailiwick is to look at a customer's part spectrum and come up with a solution that'll cover as many of those parts as possible while giving them the flexibility to change from one component to the next. We have systems that switch chucks to mandrels, the collet chucks to fixtures, back to a chuck. There's so many different ways to give flexibility and give the customer the ability to grow in the future. What I say to people is the best judgment of quality is to open the box, and David hit the nail on the head. When you make something once, the room for error is infinite. It's the expertise you gain over the years doing applications that make you the supplier people want to come to. And the fact that you stick with a customer, even if there is a problem, through it, and give them the confidence that you're going to be there before, during, and after the sale.
Awesome. Thank you, Larry. So we'll wrap up this round of questions with Michael at Shunk. So how does Shunk decide the right work holding technology for a customer's project?
Yeah, I was thinking about the question, and I think I'd kind of answer it in two ways, actually. So the first is maybe a more simple, straightforward way. Is when you're thinking about work holding, you need to know the machine type, the lot size that the customer's running, how the material is incoming, how the material is going to be outgoing, is it automated, how is the part being loaded, are there many different types of families of parts? So I think all of these points are going into the equation. And there's a lot of different type of work holding solutions to address those different points along the way. However, I think one thing I would like to mention is that if some of those things, if the machine type and the automation isn't necessarily decided, what I would encourage is that people are thinking about work holding earlier than they might normally think to put it in, because actually work holding can play such a huge component into the overall process, and also the way in which a process is automated, for example. A lot of times, so the one way to do that is, as an end user, you're thinking about implementing, or you're thinking about how you need to produce this new family of parts, or this one specific part that you have a new contract for. As you're thinking about how you do that, I recommend bringing in partners from the, the different, from different suppliers together with the machine tool builder and dealer, so that you can actually talk through a complete solution. Because a lot of times, by bringing all those right partners in, knowing what is possible with work holding might influence the machine type that you decide to go with, or it might influence what style of automation you decide to go with. For example, you may just get a single standalone machine and a robot, and then you're trying to figure out how to automate this super flexible, or this huge family of parts, when in reality, if you would have talked about the work holding and the processing and the number of families of parts with actually almost, a panel of people from the different suppliers, you might have arrived at something that's more along the lines of pallet automation, and you could have combined 0-point quick change pallet systems from the work holding team. Or, we've done some very interesting solutions on FMS systems, flexible manufacturing systems, that incorporate power chucks in a pallet storage system. And, just like David and Larry were saying, we really believe in offering engineered solutions and partnering with the customer, not just providing a part out of the box and we're going to stick by it all the way through until it is working and running. And a lot, just like David and Larry were saying, sometimes it's the customer that's pushing us to test the limits of what's possible with work holding. And so that's actually when innovations are made, and when we're actually pushing the limits of technology, is when we're participating early on in that front end, pushing the boundaries of what's possible. So like I said, the simple answer there is, what's the machine type, how many parts, the variety of parts, and whether it's automated or not. Those are 4 good things to be thinking about work holding and how it influences it. But the more complex answer is, talk about it earlier on and bring a panel in to talk about different types of solutions, because you may be surprised how work holding could also influence other selections in the overall picture.
Great. Thank you, Michael.
Can I add to that a little bit, if I may?
Of course you can, David.
Yeah. So, and Michael hit on a good point there. Getting in conversations with your customer is important. And I'm sure Michael and Larry have heard all this before. Hey, I have this work piece, I need to hold it. Well, if the engineers didn't think about how they're going to process that work piece, where do you hold that part now, right? Oh, you can't hold it there, I need to process that part. Oh, you can't hold it there, the tolerance isn't good. So, to Michael's point, yeah, we all need to think as a group, you're going to process this thing, but how do you do it, right? And that earlier on in that discussion, the work holding folks are like us, the better off the end user probably is. Thank you.
Awesome. Thank you, David. So we'll start with Larry on the next round as we ask, we'll start asking about clamping technologies. What are the advantages of these advanced clamping systems that are currently out there in the world?
Predictability, repeatability of setups, going from one part family, doing production on another part family, coming back to the original part family, and repeating a successful setup time and time again. Michael hit on a really valid point. Between 0-point systems and palletized automation, whether it be a multiple pallet machine or a single pallet machine, you have the ability to give people much more flexibility than they had in the past. I think one of the questions that came up was, what's the difference between a 0-point system and a ball lock system? I liken it to, it's the difference between a Bridgeport and a 5-axis machine. Ball lock was one of the first quick changeover systems on a milling table. it repeats within, I don't know, half a thou, if you're lucky. Where with 0-point systems, and Michael's is the same, we're all 2.5 tenths repeatability. So the fact that you can do your initial setup and not have to constantly re-indicate, reset, once you have that base on the machine, you can become ultra flexible. And now you can accommodate a different part spectrum also.
Thank you, Larry. So we'll go to Michael with the same question. With the advanced clamping systems, what are some of the advantages that you're seeing right now on the market, or in the market? Sorry.
Yeah, maybe I'll tackle it in a general way. And if I think about what work holding can affect, with what clamping systems can affect, and what it can affect is how you clamp the part. So basically, how are you actually clamping, locating, fixturing the part? It can you can also affect how many parts you're clamping. So are you just clamping one, or are you clamping 50 at one time? And you can also affect how fast the changeover is. And so when I think about those three things, by how you clamp the part, it's just like David was saying, you got to be thinking about the tolerances on the workpiece, where the datums are. I remember making that mistake very early on in my career. I've been in work holding since the beginning of my career, so about 15 years now. And I started off as a design engineer for magnetic work holding. And I definitely made some mistakes by ignoring the datums on a workpiece and just thinking that I needed to hold this block of material without consideration for the tolerances and it was very simple-minded. So we're talking about datums and tolerances and how you clamp the workpiece, and especially with advanced clamping systems and 5-axis technology, how you clamp the workpiece becomes really critical with the kind of access that you're having to it, because you can do more in one operation with multi-axis machine tools than you would have been able to in the past with more limited 3-axis machines. And so how you clamp it, you need to be maximizing the rigidity while also maximizing the accessibility to it. So clamping on as little material as possible, but you also need to make sure, like David was mentioning about the new centric vices, you need to have high clamp forces, because if you're not having those high clamp forces, you're not going to bite into the material to hold it rigidly while you're having good access to it. So how you're clamping the workpiece can really affect your productivity, and you want to be thinking about that, the different options of vices or chucks that are available, making sure that it's allowing you good part access. And then another big one, I'll save the third for maybe later, but another big one is how many work pieces you're clamping. And I think that is consistently overlooked, and it's a really important one. I was just talking through a scenario with someone a couple of days ago, and instead they were making 4 of these Glock slides or 4 of these gun slides on a Haas vertical, and we're looking at a solution that was actually a fairly reasonable investment, that they could have been making actually 46 on this same machine table. And what that does is, without actually adding to the footprint in your machine shop, or without actually, it's allowing you to actually get much more throughput and productivity, less changeover, less tool changeover, doors are staying closed longer, and you're producing much more much more finished parts in a given amount of time, without actually buying a new machine. And this particular one, this was in California, which is very space restricted. So where you're having space restrictions, think about how you can put more work pieces on one table, rather than just getting another machine to make another 4 parts. Think about how you can crank out more in a single machine. So I think those are 2 big ones, is how you're clamping the workpiece, and the advantages that advanced work holding technology can offer, and then also how many work pieces you're clamping.
Thank you, Michael. So we'll have David wrap up this round of questions. What are you seeing as far as the advantages of the latest and greatest clamping systems that are out there on the market?
Well, like Michael touched on with the centric vise, right? It's you lift that, if it's near the table, it's obviously going to be rigid, right? You lift it off the table to get the tooling clearances you need on a 5-axis machine. right? You're talking about rigidity, you're talking about work holding strength, all those type of things. And that's what we do offer with our Evo Grip. Again, the big one goes up to 18,600 pounds force. So that's a lot, right? But also ease of use, right? Let's make it easier to the customer. Maintenance, let's make the maintenance easy for them, right? Let's give them a little cheat sheet, what they need, if they need maintenance, when do they need it, right? Simple things like that. Okay, it's an advanced, but we're helping the customer, right? And it's about time. And if you can have these conversations early on, maybe you can get rid of one of the machines you were going to buy and not buy 4 and just buy 3 instead, right? Things like that. So I think that's the important part. And again, it comes down to your discussions with your customer, right? But ease of use is the big one, right? Especially when shops that are growing, they're getting new personnel all the time. And if we can make a device it's easy to use, easy to explain, if you need to change a part out, it's easy to do. Those are the type of things that we like to do, right? As those personnel changing it out, there's no time loss because time, let's face it, that's the only thing we can't buy, right? In life, in a machine shop, you can't buy it. So you got to provide a call back to that to gain that time back.
Awesome. Thank you, David.
Yep.
So we'll go to Michael at Shunk with our next round of questions as we start off with, what advantages are you seeing with magnetic work holding systems?
Oh, is this question just for me, Jake? I feel like you teed me up here. That was actually my, like I said, I actually started in this industry in magnetic work holding. So I used to only work with magnetic work holding, and there's actually, it's amazing the amount that you can do with magnets. It's a super flexible system. So if you think about a vertical, a 20 by 40 vertical, if you had a magnet on that whole table and you're doing a lot of steel plate work, for example, no matter what size of material that you put on that magnet, it just clamps, it just pulls down. So one of the easiest ways to set something up like that when you're doing a lot of different size steel plate work is to just have a couple side stops to set your X and Y. And the Z is going to naturally be set by the magnet. But it's great for steel plate work like that because, like I said, it can cover any kind of different size. And if you also think about how you would normally do steel plates, was 1 inch thick steel plate, something like this, right? Vices can be very challenging because it's normally, they can be very long and wide. You may need a few different vices to clamp it. It may not have the stroke that you need to actually get to reach all around the plate. So then a lot of times people end up toe clamping it down directly to the T-slot table or putting on 1, 2, 3 blocks and just putting some toe clamps on top of it. Now you're having issues with vibration. You don't have access to the entire face of the plate. So magnets are a great way to actually, because you're clamping the whole surface, it's actually mitigating vibration, and you're getting a really good hold on the workpiece. And one thing I like to say is that when you're working to hit really tight tolerances on flatness and parallelism, magnets are a great way to do that. They also, you can there's accessories you can purchase with the magnet that are kind of self-shimming pole extensions. And what they do is they're self-leveling and they actually meet the workpiece where it is so that you're not distorting the workpiece. And tools like this, strategies with magnets, are a great way to achieve good tolerances on flatness and parallels.
Thank you very much, Michael. So we'll go to David at Imugi with the same question. What kind of are your thoughts on the magnetic work holding systems that are currently out there?
Well, at current, we use quite a few of them to manufacture our goods, to be honest with you. We have one in our building that I don't know how big the table is, but they turn it on and the lights dim in the next town, right? But certainly, ease of use and setup is a big one. Like Michael alluded to, no more clamps on top, right? You turn it on and that thing is sitting there. The holding force is exceptional. There's a lot of clearance around it. You can almost go right to the table, right? With just a few millimeters of clearance. It's good. A lot of advantages to it. Tooling wear because of the rigidity, those types of things. But the big one is probably ease of use with a magnet, right? Probably really is, quite frankly, especially on a big plate like Michael alluded to. If you have that system, you can put down there and use your little mallet to center that thing or wherever it needs to be, or your stops and the X and Y, and yeah, it's It's certainly got some advantages, but I think it's ease of use and being able to machine all around it is the big ones.
Awesome. Thank you, David. So we'll have
Yep.
Larry wrap up this round. So what are you seeing from magnetic work holding as far as the advantages out on the market?
They pretty much have every point. Flexibility, the ability to hit 5 sides of a part without having to reclamp or reposition. The ability to create extreme flatness and rigidity. And as long as they're used correctly, a magnet can fix a lot of problems you're having with standard or conventional work holding. You grab a thin wall port with a vise or a chuck. At some point, you're going to have some kind of distortion. With a magnet, as long as you're not distorting it with your magnetic force, you're machining it in its natural state, so there's no flex back. The other thing I always say, especially with, you would think magnets are like black magic. You see people sometimes and they're like, I never thought of that. Again, it offers a lot of flexibility to a customer, the ability to adapt the different parts in different situations without changing work holding.
Awesome. Thank you, Larry. So we'll also start with David over at Imugi for the next round of questions. How do modular work holding systems help deliver some flexibility to the end user?
Well, it's right in the question, really. Modular and flexibility, right? If the ease of use to adapt from one workpiece to the next or go from one part family to the next part family. We do some work for a very common rifle scope manufacturer. All the different sizes on those things, right? We can use one arbor and many work pieces can go across the same arbor. And like these gentlemen will attest to, sometimes the work holding is more of a commodity purchase than a perishable tool. It's the replacement parts that are perishable part, right? So if you have that commodity tool that you can adapt to just by ordering a new bolt or a new expanding element or whatever, it really adds that flexibility and ease of use to the customer for sure, right? For sure.
Thank you, David. So go to Larry with the same question. How are you seeing the modular work holding systems deliver flexibility to your customers?
I feel like modular work holding is a term from like the 90s. I kind of started in this industry once I left manufacturing, working for a modular work holding company. If you don't have modularity in your work holding now, you're buying the wrong work holding. Michael started to talk before about 0-point systems. 0-point systems give you the ultimate modularity, the ability to have a magnet. And that doesn't mean your magnet can't be put on and off the 0-point system either, depending on the magnetic configuration. Again, I'll use my favorite term, Jake, flexibility, man. As long as you're giving flexibility in your setups. And the other thing I'll say is you have to have buy-in. My favorite thing to say is from the shop floor to the top floor. How many times have you had the owner of a company? Sorry. How many times have you had the owner of a company come out and say, this is what we're doing? The operator they don't want it to work. It's not going to make their job easier. If you can prove that I'm going to take less time, make your job easier, and let you produce more parts, now you become the hero. We go in with solutions. They determine what works best for their application.
Awesome. Thank you, Larry. So we'll wrap up with Michael over at Shunk for this round of questions. How are you seeing modular work holding deliver some flexibility to your end users?
Well, I like what Larry said about the term. I think modular work holding is could cover a lot of things and probably should. If you're not using modular work holding, okay, there's a lot of cases where it requires kind of dedicated fixturing, but modular work holding covers a broad spectrum of technologies. And one way I might think about it is with modular work holding in terms of how you're clamping the workpiece. I think about, kits that are almost like building blocks to allow you to clamp many different styles of work pieces regardless of the size. And one way that we achieve that is with a 0-point style modular work holding system that can go on a grid plate and be attached anywhere on a 50 millimeter or 2-inch or whatever grid pattern you want. You can attach this 0-point style clamping unit, and now you can place those wherever you'd like on your table. and then all you need to do is put in some clamping pins into the workpiece, and then you're now like in control over where the clamping points are in the workpiece. And it's a really great way. We see it a lot in tool and die manufacturing, is using this style system, putting clamping pins into the workpiece. A lot of the OEMs or the owners of the tools and the dies and molds, they're even allowing for these threads and counterbores to be placed in the workpiece according to where it needs to be held. So that's a pretty common practice in terms of how the workpiece is clamped. And then I love what Larry said about taking that a step further to quick change pallet systems, which is, modular work holding. And it's allowing you to change over really quickly. To the same point David also mentioned about the labor and making and that, the scarcity of labor. And one big challenge is finding people to do setups for you, and having that person who can actually set up or make a new setup, change the setup, write the program, and so on. And so we need to be very selective with how we're applying our labor and make sure that they're not doing tasks that aren't necessary, that are repetitive. And one way to do that is by using quick change pallet systems to make that setup super repeatable. And just like Larry said, if you could actually have, that's what we have on our 3-axis vertical sitting right outside. On the other side of this door from me is a quick change pallet system. And next to it is a cart of all different types of work holding. One of those types of work holding is a magnetic table. And if we find a job that a magnetic table is the most appropriate for, all it means is taking a couple vices off the Vero S, the quick change pallet system, and now putting that magnet on there. And it can be done in a matter of minutes. And so I think that's another really big advantage and huge aspect of modular work holding is the 0-point systems for the faster changeover and more repeatable.
Awesome. Thank you, Michael. So we'll go to Larry over at SMW Autoblock with our next round of questions. What are you kind of seeing as far as the benefits of automated work holding solutions, and what are the kind of newest technologies when it comes to this automated work holding?
Kind of an object or a subjective
Yeah.
question, because the customer dictates kind of that, how much they want to automate a setup. Or, Michael hit the nail on the head, the lack of qualified candidates. I was in a shop not all that long ago, and I said to the guy, "Why is there a piece of sheet metal over your controller? There's 2 holes." He goes, "Look what it says, yes and no." He goes, "I can't find people, so I want now somebody, the E stuff is only an emergency, and green means go." And I just shook my head, walked away, and thought, I'm glad I don't work here. But it's interesting because the advantage to automating is, people's impression of automation used to be used that have hundreds or thousands of parts, and that's the only way you could justify a robot. In our own facility, we're just getting into robotizing. We make one of everything. I mean, if we make 3, it's production. So for us, it's going to give us the flexibility to change from one part to another without relocating, re-indicating. And you can predetermine your locations. You can predetermine the order of which you're going to clamp your parts depending on the process the customer has. How many times have we walked into an account and over the course of a year, we see the same product in 4 different shops, and they're all processing in 4 different ways. What works for them the best is what I always say to people. You choose what you want to automate. We will make recommendations based on best practices, but that decision has to involve the customer, the operator, their engineering staff, their process engineers, their application engineers. If you don't involve the whole team, it won't work. It'll fail.
Awesome. Thank you, Larry. So we'll go to Michael at Shunk with the same question. What are the benefits that you're seeing of automated work holding systems, and kind of what are the newest technologies out there as far as the automated work holding?
Yeah, and agreed with what Larry mentioned there. I think it's really important to consider all the variables around automation when you're trying to decide what type of automation to to choose for your application. I think that's actually a really critical point is, and that's one thing that's evolved a lot in the industry as well in the past 5 to 10 years is the different varieties of automation that are available and also standard off the shelf. And they're easier to work with, easier to program than ever. So what I mean by the different types, and actually I can send a link in the chat or something. We have a great website on our, a great landing page on our website that actually shows you the different types of automation, and it helps you kind of maybe learn a little bit about what might be right for you. And what I mean by that is a lot of times what we think about when we think automation is a robot moving a workpiece to a machine from a some sort of storage bin. And now there's more ways than ever to do that. So that could be one, robot loading, where it's just direct workpiece loading. And then you have all kinds of different options on how you're actually presenting the workpiece to the robot, different flexibility with different handling units, shelves that have different cutouts for different size workpieces, many different types of storage units that allow you to be more flexible with what's being presented to the robot. So that's one, is direct workpiece loading. Another is pallet storage. And you're seeing more and more, almost all machine tool builders are having some kind of palletizing system provided with certain machines that you can just get. You can get this machine with one table, or you can get it with 35 tables, and you can just manually clamp your workpiece in that case. So that's pallet storage. Another one is flexible manufacturing systems that are actually, you know, these big systems like a big FASTM system, where it's actually delivering the material and the work holding to the machinist or the operator who's actually being presented with the material, with the work holding and a loading station. And they have a setup sheet there that's telling them what to do. They load that into they load the workpiece into the work holding, and then it goes into storage until it's, or into the pallet system until it's ready to go to the machine. And those are actually evolving quite a bit, where we've actually participated in a lot of projects recently where they're not only are they having pallet storage, but they're also doing automated workpiece loading. They can actually increase your capacity for tool storage, so they can incorporate additional tool storage systems into the FMS systems. They can be doing in-process inspection and so on. So there's a lot of different things with automated machine tending, that a lot of different ways to automate your machining processes.
Awesome.
And yeah, I'll leave it at that for now, Jake.
No worries, Michael. So we'll go to David to wrap up this round of questions. And, you know, obviously talking about the automated work holding, what's kind of the benefits you're seeing, and what are the latest technologies that you are seeing?
Well, when you talk automation, the biggest thing for the end user, the customer, is time, right? We talked about it earlier, but anytime you can help an automation for them, whether it's be to change use a 0-point system on a 5-axis to change out the different vices, or a quick change connection on a conventional hobbing, shaving, shaping machine, that type of thing. Anytime you can provide them that type of automation so they don't have to interact with the tooling, it's really, really saving them a lot of time. And, you know, we have one design we did for a very large automobile manufacturer. We have hobbing arbors, shaving arbors. We don't need a tool. You don't need a wrench to remove them or install them, right? And we've been doing that for a long time. And that automation helps. And it also helps with the workforce, because, again, it's easier to train somebody to hold it here and press this button than it is to take that wrench, torque it to this, do that. You know, there's no bolts involved. And, you know, with the 0-point systems, you know, you can have a very repeatable run out, you know, 5 microns or, you know, 2/10, something like that, with a high pull out force. There's even cases where we have put the 0 points on a pallet, on a plate, and had the pull studs, if you will, right in the workpiece. So there's really no vise either. You put them right on that 0 point and you clamp it down, right? And that's ease of use, right? Bringing that time back, even though it's really not automation, but from there, you can have it robot loaded, robot unloaded. We visited a shop in Germany that's using our tools a lot. And they have, you know, it's common, I guess, in a lot of shops that, you know, one robot can service 4 or 5, 6, 8, 10 machines, right? It's all in the programming, and it sits in the background, and it has a little railroad track that it runs on, and all the shelves for all the tooling and the different vices or work holding elements. And then when that machine's done, it changes it over, right? And for your tools to be compatible with that robot, to be compatible with the load unload system, not just for the tool itself, but also the workpiece that gets loaded on, right? Got to make sure you're compatible for that, so that automation can interact with your device without jamming the part, right? Without putting it on cocked or anything like that. So yeah, when we talk automation, the benefit is always time, always.
Awesome. Thank you, David. So we'll go to Michael to start our next round of questions. Where do you see Industry 4.0 playing a role in current work holding solutions?
It goes back a little bit to my first, or the first question about kind of the developments of work holding technology. And I see work holding just continuing to play a part in the overall ecosystem of industry 4.0, 5.0, whatever you want to call it. And that relates to having more electrification of work holding, more data available in order to give feedback to and confirmation of the clamp force, of workpiece detection, and so on. And we were actually just at a conference last week, and NVIDIA did a presentation on their Omniverse. And what we're seeing more and more is this playing a role in production facilities and manufacturing engineers' development of those manufacturing facilities. And what the Omniverse is just basically a digital twin of the entire production environment. And so one way that we participate in that is to make sure that we're having the data available that's compatible with those types of systems. And that's what I think about when I think about the future of Industry 4.0 and so on, is digital twins becoming more and more standard, and they're allowing you to actually de-risk a lot of your investment and test things out in a digital way prior to just jumping right into the real world. And so even without talking about the work holding devices themselves, it's actually also just making sure that we're able to provide that data that is working with your digital environments, where you're actually doing the simulations and design phase.
Thank you, Michael. So we'll go to David at Imugi with the same question. What role are you seeing Industry 4.0 play when it comes to designing current work holding solutions?
Well, if we go back a little back further than that to Industry 1, Industry 1 was basically steam engines, right? And then we had electricity. 3 is automation of machines. So 4 is implementing, right? Implementing smart solutions to this stuff. And again, digital transformation. A lot of our customers, we give a 3D file to them so they can lay out their machine. They can check their tooling paths exactly to the scale. So yeah, before they make the investment, they can research and find out what's better for them. And it's all, the benefits is efficiency, really, when it comes to that stuff. And it can be simple things. It doesn't have to be as elaborate. Some things, like we put airflow control on our devices, like these other gentlemen do as well, I'm sure. And that's just a simple thing that tells you if a part's loaded or not, right? But it all goes back to efficiency and how well you can get that. Never mind the how it's capable to remove on the machine, put on the machine, but tooling paths and clearances when you're laying out a project in the machine with the actual work holding, that's a big one for everyone, right? The customer gets a good feel of how close they can get to the part. Can they load the part of the machine, especially if you have a long machine going over a big arbor or something? You need to be able to put that part in and then move it into the machine spindle. So there's a lot of space needed. And we can all do the math, but when you see it right up front, it's a little easier to do, right, than the math. Okay, so that's what we see. Yeah.
Awesome. Thank you, David. So we'll have Larry wrap up this round of questions for us. What role does Industry 4.0 play when it comes to designing and implementing the new work holding solutions on the market?
I think that you're seeing the beginning of that in our industry. We're a very small part of a very large industry. And I think the ability to have data is the most valuable thing people have. And to be able to provide that data and give people solutions. The other thing is it's getting harder and harder to find you know, especially like 5-axis machines with trunnions, with either hydraulic or pneumatic through the center. And with the electrification and the electronic monitoring of work holding, you've done away with that problem. I mean, it operates at about 24 volts or 48 volts, depending on the setup. And you'll see that it gives you such flexibility and the ability to expand beyond the horizons you thought you were capable of. It'll actually let you take a machine that might not be the latest technology and update it to be the latest technology and to utilize that. The other beauty of electric work holding is you power to open it, you power to close it. You don't have to have constant power to it. So it's kind of like we do with vices and things like that, you know, or APS or 0-point units. Spring to close, air to open. I mean, you know, you're always clamped unless you don't want to be clamped, you put air to it. So similar with electronics or electric, you're now giving them the ability to offer a different solution to their work holding and to their manufacturing.
Awesome. Thank you, Larry. So we will start the next round of questions with David at Imugi. As I get to ask you, how has work holding design changed in the past few years to make them more efficient for the end user?
Well, for Mugi, until our EvoGrip line, we didn't really have an off-the-shelf line, right? So it was always a conversation with the customer. What are they looking for out of their work holding? What part do they need to process, right? And you work closely with them and design it for them, right? So it's not off the shelf. It's made for their machine, their environment, their workpiece, their machining operation. And has it really changed? I guess it has, because we've evolved with the customers that have come up through that, right? But a lot of this goes back to maybe the first question. It's all those conversations you have with the customer, right? Getting to know them, getting to know their operation, what they expect out of it, and quite frankly, being honest with them. Sometimes customers, and these other gentlemen can attest, you know, they ask for the moon, right? Okay, we may get them 3/4 of the way there, but sometimes the moon's pretty far away, right?
Yeah.
So we have to be reasonable with our customers as well, right? We can't oversell something either, right? But maximizing their uptime, that's a big one, right? Maximizing the ease of use is certainly a big one. And not just ease of use of interacting with, but what's the maintenance schedule? Is there a maintenance schedule? That type of thing, right? Quick change connections, certainly that really changed a lot, right? With these 0-point systems, especially for 5-axis machining, where you can the same part in a different family or a whole different part altogether within minutes, right? Or seconds, really. And that's the bonus here, right? Getting the customer on and off the machine as fast as they can, and get that time back for them.
Awesome. Thank you, David. So we'll go to Larry with the same question. How have you seen the design of work holding change in the past few years to make things more efficient for your end users?
You know, David and Michael both touched on this. You have the ability to take off-the-shelf components, customize what the customer needs for their specific applications, if you have to, and allow them to use standard components, because there's nothing worse than, you know, we sell diaphragm chucks, we sell special fixturing, we sell special chucks. The problem with that is it's limited to that part specifically, or that part family specifically. With using standard components, I could take off one set of vice jaws or chuck jaws, put on another set, and do a whole different family of parts just by adapting standard special components to a standard base product. That way, if a customer has an unfortunate crash, you know, you have a special or design and build, it can be 12 to 16 weeks to get another one. With this, you pull a standard component off the shelf. If we've already made it, it doesn't take any more than 4 to 6 weeks to supply it. So you cut that time in half to them. And any customer that's been in manufacturing for any length of time, any specialty component, if they don't buy a backup, you best suggest it, because the first thing you get is, why didn't you tell me? Well, I did tell you, you refused to spend, you know, the money. So reality is you have to get their expectations in line with the ability of what they're trying to do.
So thank you, Larry. So we'll have Michael wrap up this round of questions over at Shunk. How have you seen the work holding design change in the past few years to become more efficient for your end users?
I think I've just used a very simple example in that question to answer it is, how has the design changed to make it more efficient? One good example is one of our newer chucks where we used FEA analysis to figure out how we could weight reduce it, and make, which by weight reducing that without losing any strength or rigidity in the chuck, is we actually used FEA in our design to weight reduce, which makes it more efficient. It means that when you're turning that spindle up and turning that spindle down, it decreases the time it takes to do so. That buys you cycle time. It also is a green initiative. We do see that demand coming a bit more. For sure, we see it a lot in Europe. We're starting to see it a little bit more here and there in the US. Customers asking to or needing to asking questions about how we're contributing to that carbon footprint, or how we're thinking about green energy saving initiatives. And so that chuck does that. It's having that weight reduction in it, making it more efficient both in cycle time and making it more green.
Awesome. Thank you, Michael. So we'll go to Larry over at SMW Autoblock to start the next round of questions. Obviously, the over at GIE Media, we cover aerospace, medical, defense, and EV. These are all places where precision in manufacturing matters. So how is the right work holding solution chosen to ensure that precision?
It depends on the customer and their process and the application. Again, like I said before, you could go to 4 different places and see them process a part 4 different ways. It doesn't mean one way is any better than the other, just what works for the customer at that point. We make recommendations based on best practices and the ability to remain flexible and accommodate multiple parts families within the work holding they purchased. Michael hit a very strong point. Weight has become a problem. 5-axis machines, you not only have to worry about clearance, it's weight limitations. High-speed machines is the same problem. You have to have the ability to give the customer what they want, when they want, how they want it, and pay for what they want to pay for it. And that's pretty simple as I can make it.
Awesome. Thank you, Larry. So we'll go to Michael once again at Shunk with that question. With precision, or when thinking of precision, how is choosing the right work holding solution done?
I think if we're speaking about precision specifically, a lot of it comes down to how you're clamping the piece. Like Larry was saying, you need to be thinking about the datums and the tolerances. When it's very tight precision, a lot of factors can come into play. And then all of those things are further more complicated when you start talking about automation. So if we just leave automation out of it, though, and you talk about precision, you need to be thinking about that's where the design of the work holding, and we're sitting amongst 3 very quality work holding companies here, but that's where the quality and really some of the nuances of how the work holding is designed becomes critical. Are you having 4 bolts here or are you having 2 that are, where are the bolts positioned on how the jaws are being clamped to the master jaws? Things like this. These are the things that start affecting the precision of the clamping, and things like jaw lift. Are you having less than a thou of jaw lift, or are we talking we're having 10 thousandths of jaw lift? Is it repeatable? Is it 7 thou of jaw lift right now and 15 thou of jaw lift, or let's say 7 thou and 3 thou? Is it bouncing up and down? Those are the things that become really important, and that comes into the design and the quality of the work holding that becomes so critical. And also you need to be thinking about the type of work holding. There are instances where, speaking about a lathe, for example, there are instances where a sliding jaw chuck is going to have limitations to what it can do in terms of jaw lift and making sure the part is seated in the Z-axis. And you might need to consider a kind of pull down chuck, or so those are the things that I would be thinking about, is when you're thinking about the technology and you're thinking about the types of tolerances you're trying to hit. You need to be cognizant of that and what types of technology you're choosing. I know it's a little bit vague, but there's just so many variables in terms of how you actually choose and how you answer, that it can come down to the limitations of certain technology and picking the right one.
Awesome. Thank you, Michael. So we'll go over to David at Imugi to wrap up this round of questions. When precision in manufacturing matters, how is the right work holding chosen?
I think, the end user needs to do their research, quite frankly. And we have three good panelists here and three very good companies. Is it going to be a commodity tool? You're using it for one project, tool product, multiple projects, that type of thing. There's off-the-shelf solutions, those issues. There's new supply, design and build, like we primarily do. But you need to have that conversation with your supplier. You need to be comfortable with them. And when they do give you a quote, you need to make sure it covers all the scope of supply, the run-out values they can expect from it, repeatability values. And again, with work holding, it's not, that's not the run-out value in piece one. That's the run-out value in piece 80,000 too, right?
Sure.
So, we can't pull the wool over anybody's eyes. You got to be accurate with this stuff. But as the end user, quite frankly, most of the time they do get 2 or 3 quotes, right? And they need to be comfortable with their supplier. What were the questions asked by their supplier of work holding? Did they think about the part themselves, right? Did they make suggestions? Well, we should maybe, put 2 more cents into our blank, maybe to get a better datum to hold on, that type of thing. But as well, when you get your quotation, make sure it covers all the details, the scope of supply. Does it have a good drawing? What are the values on it? And I think that's important when they go to choose a work holding supplier. Yes, you want the best you can get, but you also want a company that you can work with, right? And at some level, it does come down to relationships, especially long-term relationships, right? Where if you've been a good supplier, you will get that nod before the other companies, perhaps in a certain environment or a certain application. But working with them, with the end user, they'll get the feeling who they like better. And it does, hey, listen, the tooling needs to do the work, right? They could like the person all they want or have a good relationship with, but the tooling doesn't work, you're out, okay? So it needs to work. But we need to make the end users and the potential customers feel very comfortable up front, with the conversations that we have, with the information that we ask for, right? And if they don't have certain information, like sometimes it's too early in the process, they don't have all their cutting data yet, well, then we give them, variables that they can use for the cutting data. Hey, if it's this much, we should do this. If it's over this deep cut, we should probably take this approach, right? So they need to be comfortable with their work holding supplier. We're going to be friends for a long time.
Awesome. Well, thank you so much, gentlemen. That just about wraps up today's discussion, but we'd like to thank our sponsors, Schunk, Imugi Franken USA, and SMW Autoblock. And obviously a massive thank you to Michael Gantz, also David Jones, and Larry Robbins. Thank you so much for your time and expertise today, gentlemen. I hope you guys all have a great rest of your day.
Thank you,
very much. Appreciate you having us.
Have a great day, everybody.
You can listen to all of our episodes of Manufacturing Matters and Lunch and Learn podcast from the MFG Radio Network on Spotify, Apple Music, and on our websites, todaysmedicaldevelopments.com, aerospacemanufacturinganddesign.com, defenseandmunitions.com, and evdesignandmanufacturing.com.